a first step in getting good at solving proportion equations is to change the form of an equation so that it's easier to work with. Much like the factored form of a trinomial helps you to solve for x, easier than the expanded form for a trinomial, we often will need to change an equation algebraically in order to make it easier to work with. So this is called fraction busters, and the goal is to change an equation that's difficult into an equation that's easier to deal with. So example 1 here shows 12 hundredths x plus 7.5 minus 2 hundredths x, equals 2 hundredths x plus 3. Well, I certainly know how to add and subtract decimals, and so do you, and we could continue to do that, but it's much easier to deal with the equation 12x plus 750 equals 20x plus 300, and we can get to that result by multiplying every term in the equation by 100, which will turn this into 12x. So we're going to multiply by the smallest value that clears the decimal. It's going to be a factor of 10, or a multiple of 10, that is. So multiply by the smallest value that clears the decimal. And in this case, 0.12 was multiplied by 100. And take a look. 12 hundredths here, this value, or this term, can be written as 12 hundredths. Does it make sense that multiplying by 100 not only moves the decimal point over, because 12 hundredths times 100 is actually 12, but in the sense of the rational expression, 100 times 12 hundredths equals 12. We're allowed to do that if and only if we multiply both sides of the equation by the same non-zero value. So if we apply that idea in number 11, I would like to move this decimal point over 1, 2, 3 spaces so that I have 2x equals something. I can do that by multiplying every term by 1,000. Or I can do that by rewriting the term 2 thousandths x as 2 thousandths x, and multiplying both sides of the equation by 1,000. The result is the same. 2x equals 5,000 is a much easier equation to solve than this one. But because we're using the multiplication property of equality in either case, this will not change the value of x. In example 2, well, let's look at example 3. We have the equation x halves plus x sixths equals 7. So I'm going to multiply by the larger of these two denominators, which in this case is 6. Now that works in this case because 2 is a factor of 6. So multiplying by 6 will give me 6x over 2 plus 6x over 6 equals 42. 3x plus x equals 42. 4x equals 42, and will allow me to solve for x easier than by adding and subtracting halves and sixths. When the two denominators are not compatible, let's say 3/7 plus x thirds equals 7. Let's make that another number, equals 5. Then we're going to have to multiply by both 7 and 3 because neither 7 nor 3 is a factor of the other. So each of these will be multiplied by 21. So 21 times 3 over 7 plus 21x over 3 equals 21 times 5. 21 divided by 7 is 3, so I have 9 in the first term plus 7x equals 105. Easier equation to solve. So let's apply this in example 7, which reads 3x over 10 plus x over 10 equals 15 over 10. So not much to think about here. If I multiply each of these terms by 10, I have 30x over 10 plus 10x over 10 equals 150 over 10. Each of these is reducible. 30 divided by 10 is 3x. 10 divided by 10 is x, or 1x. 150 divided by 10 is 15. 4x equals 15. Dividing both sides by 4. X equals 15 fourths. And this is reduced. 15 and 4 share no common factors, so I can't reduce it further. I don't mind that it's an improper fraction where the numerator is larger than the denominator, so you do not have to put it into a mixed number, but you could. This will equal 12 and 3/4, not 12 and 3/4, 3 and 3/4. So 2 of these have been solved for you. This is number 7. This is number 3. Please pace yourself so that you have your work completed in time to have these checked by Thursday, so that you have the weekend to make corrections. These are due on Monday at the start of class.